Hello students, today we are in lecture number 53 of chapter 4, moving charge and magnetism. I am B S Pandey. My dear students, we have studied the different type of forces and the magnetic field here in this chapter. In today's lecture, we will study if we'll place a current carrying element inside uniform magnetic field, then how it will experience a force. Okay, so the topic, it is force on current carrying conductor. Force on current carrying conductor, or you can write the current element. This is our topic. All right. We'll start this topic using the concept of force on moving charge. Remember, already in the conductor we are having the current, and if we are having the current, it means charge is moving. We'll assume a conventional charge, positive, moving inside the conductor along the current. Suppose this is a magnetic field. Using this radar, let me draw the magnetic field. This is the direction of my magnetic field. All right. Yes. This is the conductor. The cylindrical shape I'm giving to the conductor. This is my axis. X, Y, Z. Here in this conductor, if suppose along this axis the current is flowing in upward direction. All right. If current is in upward direction, if we'll assume a charge, so it will move towards the current in the direction of current if we consider a positive charge, and this speed is nothing but the drift speed. All right. Yes. Whenever any conductor carrying current, all right, placed in magnetic field, it experiences a force, and that force actually depends upon magnitude of current, what is the length of the conductor, and in strength of magnetic field in which this conductor is kept. Okay, these are the factor. But we know that here, remember, the length of the conductor, it is L. L, it is the length of conductor. Okay, I, it is the current. All right. Here Vd is the drift speed. Already we have studied drift speed we are using. Now, my dear students, we know using the concept of force, let us consider any free charge in conductor. Okay, let us consider a free charge. Okay, inside the conductor, if we have focus over the free charge, so we can write the force as Q V cross B. All right. Yes, we know that. Now, where V is the drift speed, Here V, D we can write. Now, this force can be also written as Q times drift speed. We know that if for the time t this charge moved from one end to another end in time t and it cover the length L, then we can write this drift speed as length by time, alright, into magnetic field B. Now you can see F is Q by T L cross B. Alright, yes, the very simplest explanation of this particular topic. Q by T, the total charge. Suppose if we consider and sum up the charge, then this will give you the current I L cross B. So this will be your required formula that you will use. If any conductor placed inside magnetic field or B having the length L and current flowing through that conductor is I, then that conductor will experience a force inside that magnetic field. It is IL cross B. What magnitude we can write? So the magnitude of this force can be written as F. It is, so we are writing here the magnitude. It is I L B sine theta. Okay. In short, my dear students, you must remember this F is equals to I lb sine theta. Okay. I L B sine theta. Here, F will be maximum for which angle? Yes, theta 90 degree. If any conductor placed perpendicular, you can see here I have placed this conductor perpendicular to the magnetic field to have the maximum force. If any conductor will place perpendicular to the magnetic field to experience maximum force, and remember, if any conductor placed parallel to the magnetic field, anti-parallel to the magnetic field, the force will be 0. Alright, yes. Now, the very important thing, how we will find the direction of force. So, it's quite clear. If it is the cross product, then you can use right hand thumb rule or the curl rule to find the direction of force. If current is going in this direction, alright, and this is the magnetic field, you have to find the direction of L. Remember, the direction of L defined by the direction of I. Here the current is moving up, so the direction of L will be up, and the B, it is in this direction. So this is L, look at here, this is L and this is B. So L cross B, your thumb is going down, so the force will be here, the force will be the direction of force will be cross. I hope you understand, and this way you can find out the direction of force as well. Now let me move for the next section, my dear student. Here few example I'm giving you. You have to find the direction of force and then we will proceed for the next. But this is a very important formula. I love sine theta. You have to remember. I love sine theta. Okay, let's hit the direction here to find the direction. This is the direction of magnetic field. This is the direction of magnetic field, and this is the conductor. The current is flowing in this direction. Okay, could you find the direction of force? Kindly write down. Example 2. Meanwhile, I am giving you the second example. You have to find the direction of force in that first example. You have to find the direction of force. Alright, what will be the direction of force here? Try to find out, my dear students. Let me tell you the answer. Here, the direction of current is this one, so the direction of L will be this one. So L cross B, where is it is downward. So the L cross B, the force will be in this direction and it is perpendicular. So this is the force again for this one. L cross B, the direction of current will give you the direction of L. So this is the L, and the magnetic field is the upward direction, is its dot. So the L cross B, it is the direction of force in this way. In this direction, the force is acting. So this will be the answer. I hope you understand, my dear student. Now, the next topic will move, and then after we'll solve few important question. Okay, now the next topic, it is which is very important, the magnetic force between two parallel conductors. Okay, and then after we'll define the 1 ampere. This particular question has been asked in board. Give the heading magnetic force between two parallel conductors. Okay, and one ampere. We'll define using that concept of force between two conductors 1 ampere. How the 1 ampere can be defined. Okay, for that let me draw here axis first. Here the XYZ axis have been placed here. Conductor. Here the two conductors are placed through which the currents are flowing. Suppose it is I1, I2. All right. The length of this conductor L1. This is L2, and let separation between these two conductors is D. All right. Yes. Now we have to find the force between these two conductors. What are the values do you have? So you are having I1, I2. Let me write with that. Wait. I1, I2. It is the current in conductors. All right. Yes. D. It is the separation between two conductors. L1, L2 are the length of two conductors. Now, my dear student, here we are going to find out the force between these two conductors. Remember, we have studied right now that if we'll place a conductor inside magnetic field, it will experience a force. But here you cannot see the magnetic field directly it is given. All right, then how it will experience a force? Remember, we know that if current is flowing through any conductor, that conductor produces magnetic field around it. It means both of the conductors being placed in magnetic field of each other. For example, if we'll see conductor 1, it will produce magnetic field around it, and the direction of magnetic field will be looks like this one. This way it will produce the magnetic field. Now you can see this conductor 2 is being placed. Okay, we have given a name 1 and 2. This conductor 2 is being placed the magnetic field of which conductor? Yes, it is 1. And the direction of magnetic field for this conductor will experience a magnetic field. It will experience a magnetic field, counter magnetic field, which is in which direction? You can see the current is flowing through this conductor. It is in upward direction. It is in upward direction. So the magnetic field will be downward. Here, the magnetic field will be downward for this conductor. That is cross. If you see the magnetic field due to this conductor, you can see this will also produce magnetic field, and in this magnetic field conductor 1 is placed. So for this conductor, the magnetic field at this point will be in upward direction, and this will be placed in magnetic field dot. Okay, yes, it is very clear. You can write, my dear student. Okay, conductor 1 is placed. I'm telling you, you have to write. I will not write over this board because we don't have sufficient space. Conductor 1 produces magnetic field at point of conductor 2, and 2 is placed in that magnetic field. Similarly, conductor 1 is placed in magnetic field of conductor 2. Alright. And then we can study the force. Now, first, let me find the force, okay, that will be considered here. Before starting the force, we have to find the magnetic field also. Okay. Now, suppose B1, it is magnetic field of conductor 1. B1, it is the magnetic field of conductor 1 at 2. Remember, B1 is the magnetic field of conductor 1 at 2. At which distance we have to find the magnetic field? D distance. Of which conductor? Due to conductor 1. So the magnetic field will be mu naught I1 divided by 2 pi d. Okay, at this point the direction of magnetic field, it is downward, so it is minus k. I hope you understand. This is the magnetic field of B of conductor 1 at 2, you can mention. Now let me find here the B2. Magnetic field of second conductor at conductor 1, it is mu naught. Since it is the magnetic field of conductor 2, so we'll consider here the quantities of 2, that is the current of 2, and we have to find magnetic field at this point, so the separation is d, so the 2 pi d, and the direction will be upward, it is k cap. All right, you can mention magnetic field of 2 where? At 1. Okay, yes. Now we have calculated the magnetic field. Now we have to find the force. Now force on conductor 1 and 2. Force on conductor 2, you can write force on 2. What we can write? F2, we know that I L cross B in vector form. I, so force on conductor 2 will find the force through conductor 2. It is I2. Now L cross B, its length is L2 and direction is J cap. It is moving up. Cross B. Which magnetic field? Here magnetic field was produced by conductor 1, that is the B1. And the direction of B1, you can see it is minus K. Minus K. Okay, now we'll simplify to get equation. Here, my dear student, F2 can be written as I2 L2 and J cross minus K. It is, you can see the current is moving in this direction, J cross minus K. The force will be in this direction. It will experience the force F2 in this direction. So direction minus I, and B1, the value of B1 we can put mu naught I1 by 2 pi d, and direction we are getting minus I. This can be also written as mu naught I1 I2 divided by 2 pi d L2. Okay, in examination you will be asked to find force per unit length. So you can see the force per unit length, it is mu naught I1 I2 divided by 2 pi d, and the direction minus I we are getting. Similarly, if you'll try to find out the magnetic force on conductor 1, this is the force on conductor 2, okay, and it is coming in this direction. In similar way, if you will try to find out the force on conductor 2, you will get, let me rub this one. Similarly, you will get force on conductor 1, sorry, 1, it is directly I'm writing, you can derive as I have been derived on this one, mu naught I1 I2 divided by, all the things will be same, the length of the conductor will mention here the L1 only, nothing else. Alright, so the force per unit length will be same, it is mu naught I1 I2 by 2 pi d, and the direction you will get I cap. This is the very important. On this conductor you will get the direction of current force in this direction. Okay, my dear student. Now you can see if both the conductor are parallel, the current is going in same direction through both the conductor, they will attract each other. You can also derive the equation for the current if both the conductor having the current in opposite direction, then what will be the direction of force? You will find they will repel each other. We'll write in note point, but right now we are going to define here the 1 ampere. Okay, what is the definition of 1 ampere using this formula? So my dear students, kindly write down in your copy that definition of 1 ampere. Okay, and using this concept I'm going to explain you the meaning of 1 ampere. You have to write that I'm telling you. Now write down 1 ampere is the current. Okay, 1 ampere is the current which, when flowing in each of two parallel wire in vacuum of separation 1 meter, exert a force of mu naught by 2 pi Newton, which can be numerically equal 2 into 10 power minus 7 Newton. This is the definition of 1 ampere. How we have defined, my dear students? You can see from here, suppose if L is 1 meter, okay, it is 1 meter, and I1, I2, if it is 1 ampere, because we are going to define here the 1 ampere, this will be 1 ampere if both the conductors are separated at 1 meter and experiences a force of mu naught by 2 pi Newton. Okay, in this way we have defined 1 ampere. Alright, now you will write in note point, which is the very important note point. These two conductors are being placed and the current are flowing in same direction, I1, I2. Okay, so they will attract each other. You should write in note point, they will attract. But if through the two conductor current are in opposite sense, this is I1 and this is I2, then they will repel each other. This is very important, must remember. Okay, they will repel each other. If you will gives flight angle between these two conductors, so they will repel. Even if you will give two conductor flint that is inclined to each other, they will attract each other. Okay, although the magnitude of force will change, but it happens. Okay, my dear student. Now let me discuss few questions. Numerical question. Let me wrap this one. You should remember the formula. It is F is equals to mu naught I1 I2 by 2 pi d into L. Here the question. Suppose this is with help of sealing the two thread, a rod is suspended. A metallic rod is being suspended. Okay, of course they will experience a tension. This two string will experience some tension. Why? Because this rod having some mass. Suppose m is the mass of rod. All right. Yes. Current is flowing through this rod is I ampere. Current is flowing. By any means or method, the current is being established. Here, length of the conductor, it is L. This is length L. L is the length. All right. Now, the question. The question is, what should be the magnitude and direction of magnetic field? Here, what should be the direction of magnetic field and magnitude as well, so that tension becomes zero? You have to maintain this tension as zero. What should be the magnetic field? You have to establish here a magnetic field. Okay, over the plane of this board, you have to produce a magnetic field. We know that the weight of this particular rod will be in downward direction. Of course, to balance this weight, we need a force. All right, because if we want this tension to be zero, then this force F should be equals to mg. This is quite clear. And to find the direction of force in this direction, what should be the direction of magnetic field? You can find out. And this was the question, to find the magnitude and direction of magnetic field. Okay. We have to find the direction of current in this way. Remember, student, the direction of force on current carrying conductor you can also use by the Fleming's left hand rule, but that is the complex. I never suggest the students to remember this one. But if you remember this right hand rule, then you can find out this one also. Okay. In the direction of, we know that the formula F is I love sine theta, I L cross B. So moving from the direction of current, this is the direction of current, we have to find this force in this direction. Okay, it means in this direction. So this is the current. Magnetic field should be downward. Of course, the magnetic field we need to establish over here, it is cross. This will be the cross. Now, so the answer of direction of magnetic field we got. Now the magnitude. F is nothing but I L B. Sine theta, theta is 90 degrees, so the sine 90 will be 1 is equals to mg. What we have to find? Magnitude of field. So it is mg by I into L. If the values are given, you can find out the answer. It is in Tesla. All right. Now the next question, my dear student. Another question. On a tabletop, this is the tabletop. On a tabletop, you're having a conductor. It is being placed, okay, through which current is flowing. Suppose it is I1. The name of this conductor is AB. Alright, another conductor placed just above this conductor named CD. CD. There's a quite separation between these two. Suppose it is D and it is given. Current is flowing through this conductor also. It is I2. Okay. The separation, it is 1 millimeter. 1 mm. I1, I2 both are given. Here I1, that is current flowing through AB, it is 12 ampere. Current flowing through this CD, it is I2, which is given as 5 ampere. Alright, now you have to find mass per unit length of this conductor AB. Mass per unit length of which conductor? AB. What should be the mass per unit length of AB? No, it is placed over the top. No, CD. Sorry, CD. So that as we'll leave this conductor, it's suspended in air. For example, this is tabletop. I have placed this conductor over the tabletop and the current is flowing through this one. If I place this conductor over this one, I leave this conductor, it remains suspended in air. What should be the mass per unit length of this conductor? Remember, student, if this conductor is having some current and this conductor is placed over this conductor, of course, if it remains suspended, it means its weight is balanced by some force. You have to actually find that force. Once you will find, you will have the answer, my dear students. Okay, so I hope that I have explained it very clear, my dear student. I think it should be your homework. So this is your homework, my dear student. You will solve by yourself all the concept I've given, how you have to solve this question. In next lecture, we will study about the torque. Okay, torque on a current coil when it will placed. Remember, if you will place the conductor inside the magnetic field and the different section are experiencing the force, it might rotate inside the magnetic field. And to rotate any conductor or the particle of the body, we know that a net torque must require. So we'll study in next lecture about the torque. Okay, my dear student. And one thing, remember, my dear students, what I have noticed, because whenever I teach over this very short board and the maximum focus is to maintain the video, it is properly or not, the noise is not coming from surrounding, so might be some mistakes goes on. If you find any mistakes in my lecture, kindly notify in comment section, my dear students. Okay, so that it can rectify. Okay, thank you, students.